Solving for unknowns with prisms. So sometimes we're going to have to be able to use a known volume to solve for an unknown side. An example here is this prism below has a volume of 100 cubic centimeters. Determine its width. So looking at it, it looks like we know the length, L equals 10, and the height, H equals 2. And we don't know what's the width that runs along the side. So we're going to start with the formula for volume. V is equal to length times width times height. And it looks like we know everything except for W. So let's go ahead and plug those all in. Volume is 100 cubic centimeters. And that's equal to length is 10 times W, we don't know, times H is 2. So in a question like this, you see that we actually have our 10 and 2 sort of in broken up around that W. 10 times some unknown W times 2. But you can do multiplication in any order. 10 times W times 2 is the same as 10 times 2 times W. So I'm going to simplify that that right-hand side by multiplying 10 and 2. And so it's the same as 20 times W. Now I'm going to go back to my algebraic solving skills that we've worked on in the last couple units. And to solve this for W, I have to divide each side by 20. So W is now by itself. W is equal to 100 divided by 20, which is 5 centimeters. We have a rectangular prism-shaped pool, and it's 4 by 6 across. 4 meters by 6 meters. So here's a little sketch of the pool. 4 by 6. And we're told that we're going to fill the pool with 750 liters of water. So we don't know how tall the pool is or how deep it is, but we're going to assume that the water doesn't fill it up all the way. So I'm just going to kind of sketch out this dotted height. This is like how high will the water fill if we put in 750 liters. So the first thing we should take a look at is our units. I know the dimensions of the pool in meters, but I know the volume of water we're adding in liters. Now I can't turn a meter measurement into a liter because that's two different things. Meters measure a linear measurement, length, and liters measure a volume measurement. But I at least can turn my 750 liters into cubic meters, because that's something that then at least my units agree. I'll have cubic meters and meters. So that's where I'm going to start. 750 liters times, I want to turn this from liters into cubic meters. And I can go to my data table and find this. 1 cubic meter is equal to 1,000 liters. So 750 liters times this fraction, my liters cancel, and so I have 750 divided by 1,000. That's 0.75 cubic meters. So now I have my volume in cubic meters, and so I can go to my volume equation. It's length times width times height, and I can plug in my volume, 0.75. And I also know what my length is, it's 4 meters, and I know what my width is, it's 6 meters, and I just don't know my height, but that's okay. That's the one I'm going to solve for. So 0.75 is equal to 4 times 6 is 24 times h. If I want to solve for h, I'm going to have to divide each side by 24 so that it cancels off of my right-hand side and leaves just h all by itself. And so h is going to be equal to 0.75 divided by 24. And when I do that, I get h is equal to 0.03. And I'm not told what to round to, so I'll just use a couple of, because it's such a small number, I'll just use a couple of digits. So 0.031 meters. If I was to convert that into centimeters, that would be 3 centimeters. So a 4 meter by 6 meter pool You know, that's not a huge size pool. It's a good size, but not a huge size pool. Uh, that with 750 liters of water would only fill it up 3 centimeters high. It gives you a sense of how much water has to go into a swimming pool. It's a really, really large amount of water.